Greetings, Terraformers. You've stumbled your way deep into Terraform. There's no way out. You're using best practices, and your code has gotten bigger and more complicated. Making matters worse, you now have what used to be a simple configuration file spanning multiple root modules. Today, we'll inspire you with some concepts allowing you to paste data between multiple root modules and beyond. I'm going to take a look over here at a diagram that I've put together to help explain this topic. And to begin with, I want to point out some of the perhaps more obvious ways that somebody can do what we're talking about. I guess to highlight exactly what the use case is, in case it's not readily familiar, you are putting together all of this content with Terraform, and you get certain outputs, and you need to pass those outputs into I had said root modules, but it could also be that somebody else needs the output of your Terraform content. I spoke with someone just today that was actually taking their output and wrapping it into a PowerShell object for somebody else to consume. So very interesting and novel way to produce that. But regardless of who it's being delivered to, it's sort of the same challenge. It could even be that you're delivering it to yourself, and you still have the same challenge that you need to move data from one context to another. And in most programming languages, I think this is all pretty natural for us to envision, or even within pipelines, it's natural for us to envision. But when we get into Terraform, we start to see again how Terraform is not a programming, not a development language. It's different. And so this core concept is, you might think lacking, but hopefully I can show you some ways that are easy approaches to get exactly that. We'll start with input vars. And with input vars, we are looking at ways that we can bring data into Terraform for us to consume and use for other things, for other modules, for the configuration code itself within the root module. And so typically what you're doing is you're establishing those variables within Terraform, and you are then using them. Now you may actually pass values in via a terraform.tfvars. So you can see one of the options here is a tfvars file. If it's called terraform.tfvars, then it is automatically ingested into your code. And then when you refer to var.anything, then it will look at the values that were passed in via terraform.tfvars. What you may not have known, though, is that that file can also be a .json. I actually forget now if it's tfvars.json or json.tfvars. I think it's tfvars.json. So JSON is a compatible language that you can use instead of HCL. And this may give you better opportunities with interacting with others. So if you're expecting an input from someone else, you could obviously ingest JSON and convert it into Terraform collections, but it may be simpler and more straightforward for you to make available a JSON file that others can write directly to or amend. And as long as they are following the constructs that define Terraform collections, in other words, as long as they are producing JSON that reflects directly into Terraform collections, then you don't have to do anything, right? That file will automatically be ingested, and those values will become available because they are all standards based for Terraform language constructs. So that's probably the most obvious ways. Now, alongside that, we also have the -var command line. So when I do a Terraform apply or plan, I can apply a -var parameter, and I can provide the command line or provide the input along with that. And you can apply multiple inputs, so multiple -var parameters to define multiple values. Now, I will say that -var is easy for simple variables, but if they are complex variable types, then I would recommend against it. I honestly, I mean, I'm sure it works just fine, but the quoting probably gets a little insidious. So the var command line is good for simple, but if it gets complicated, then I would be looking at a tfvars/json file, or perhaps one of these other methods.
Right.
And
I've used the TFRs variable when like I had separate environments, but I didn't have it broken out into a remote state file yet. So like it was like very early. So I'm like, I have a dev Terraform dev TFRs, a Terraform
Oh,
QA,
right,
you know,
right.
and then I would call it using the the var file
Var
command
file,
line.
right. Yeah, and that's a good distinction. So Terraform.tfvars is automatic, but there are others that will not be automatic, and then there are still others that are automatic within certain contexts, like Terraform Cloud, where I think it will automatically consume workspace named values. There's also an auto Terraform.auto file type. So there are certain file types that are going to be automatic, and then there are others, like the one you mentioned, that requires you to specify that file. You then have to use the parameter of var file to ingest that. The artifact is the same, though, right?
Hmm.
The var file itself remains exactly the same in all of those cases. Subtle differences between JSON and HCL, obviously, but otherwise, those are all the same effective file. So then the last one and on input variables specifically is tfvar variable. So in this case, I'm defining an environment variable on the machine that is running Terraform CLI. And that environment variable has to be formed a particular way. So it's tf underscore var underscore, and then whatever variable name you want to use. That will automatically, again, auto ingestion, that'll automatically be ingested into Terraform. It will strip away the tfvar underscore part, and it will just leave the variable name at the end. So that becomes var.x, becomes whatever is after the tfvar underscore. And that's a real convenient way to set up, especially if you're using like the runner concept within pipelines or just generalized. If I have a machine that is responsible for doing all of my Terraform builds, then I can suffuse it with command or environment variables, and it will then behave according to whatever my code architecture is requiring those variables. And that may work really well. So, for instance, within CI/CD pipelines, a lot of times you're defining environmental variable sets. So I might define like a non-prod environment or a dev environment, and then that environment has all of these standard environment variables defined, and those get written as environment variables in most cases directly to the runner machine. So you can then count on certain variables to be available to your Terraform code without having to define it or find ways to define it outside of just the machine running in an environment. So those are the main input variables. Now I've got one other listed on this area, and we are looking at this area here in case that wasn't obvious. But one other area on this is the remote state, and the remote state is another way to sort of gain access to input variables. So really, all you're doing is some other Terraform configuration defined state. So it wrote all of its outputs, all of its artifacts into a state file. You then want to use that as effectively a data source within code going forward. And so I can use a special data source type for remote state, and that will allow me then to look within that state and pull out values that exist within it, outputs, objects, anything like that. So it does require that you have access to the remote state. So it's not like it is a security issue if I'm providing access unknowingly, but this is not like a hack that opens up your remote state, right? You should normally protect your remote state. If you're using the remote state data source, then you've knowingly provided access to your state, and therefore all of its values are open for that user or that machine to read. But that is another way to sort of get input vars in a way into your code. So that's the input var area. There is another one, and we've actually talked about this in a previous video a little bit, but the other one is the key value store. And this is a fairly simple concept, but not a lot of people use it, I find. The idea being, and actually, let me just go into some details on this. The idea being that I have a key value database of some sort, whether that be a secrets engine, a config map, it could be a database, it could be a lot of different things. And um, I just really want to be able to put resources into that, and I need to then be able to get the key in order to find the value. The real benefit, and this is kind of drawn out here in this, the real benefit here is that non-Terraform consumers can gain access to those objects. So it's not limited to a VM, to a container, to a Terraform, to anything, to a cloud provider. It is open to what you give access to that key value store. So if it's a database, then you may have a NoSQL or just any kind of in-memory database that uses key value store. Then you may have other applications tightly connected to that are leveraging that. If it's a vault, you may have applications. You may even have a public API that gives access to those values based upon permissions that you define for those things. So that can be a real handy way. I would dare say probably one of the better ways to share data, to pass data from Terraform. So I'm going to output to a key value store, and then later I can read from those inputs. And that's like, if I conceptually, that's the most simplistic way to enable the passing of data, but it's also the most open way. I can enable it for any number of consumers, which I think is invaluable. So I'm not spending a lot of time on this because we did talk about this a little bit more, as I mentioned in the previous video. But I can't underscore the value enough of that type of solution. So then we will touch on another one, which is probably, I don't know that I've ever seen anybody do this. Frankly, this is a method that I pulled together in the last couple of years, and I found it to be helpful for a particular use case. And I don't know yet if others share that same feeling, but that is the creation of files. So, and I've used this pattern before in just like standard development languages. So in this pattern, I need to dynamically create files to produce the content that I need, right? Dynamically written code, and that's not uncommon at all. But as applied to Terraform, it's perhaps a little bit more uncommon. So the notion here is that, and just before I define exactly how it works, as shown on the screen, the notion here is that I've got content that's being produced in one Terraform, and that content could influence what goes into the Terraform of the future, other root modules that are unlinked, unrelated. And I could use remote state to facilitate this for me, but there are some stages, some phases of Terraform that won't touch remote state. They won't touch any of the real expressions. So there are plenty of places in Terraform that require literal expressions. They must be known before apply. And there are some that are even that have to be known at the launch of Terraform. Notably, what I'm talking about is state. If you are creating, for instance, a state backend in one set of Terraform files, and then you are consuming that state backend in future Terraform files, there's no way for you to bring in remote state to fill in that value. So I think that most people probably use TerraGrunt for this type of action. They can make a very dry Terraform design using TerraGrunt, because based on the environments, it can modify exactly what that environment looks like for Terraform. And the way that I've done that is with this file creation process. So the way that it works is I have a storage account that's been built over here on the side, and it's just kind of a standard storage account within Azure, and it has a very specific, unique name, maybe even a random name. So that account name needs to go into my backend configuration state for Terraform in future runs, and it's a typically this would be, as I said, either a code practice like through TerraGrunt or something, or it would be a sneaker net where I grab that value and then go paste it into my code elsewhere to use. So I want to pass that storage account name into a provider.tf file ultimately, and that provider.tf file describes exactly what my my storage backend looks like. So I've got backend to Azure RM, storage account name, and then it's the name that matches the storage account that was created elsewhere. So what happens is I have a local provider where I can actually specify lots of just values, and that will play a role in this. But the template file function is probably one of the more critical elements. So the template file function allows me to use a template that I've defined, which I've got listed here as TF-TPL, and I want to effectively do a search and replace, find some value and replace it with another value. So by calling template file, I can specify the template file I want, and then I can give it a collection or a probably any kind of variable. But I usually give it collections or sets or something. I usually give it collections. So I pass it a map, and the template file, if we were to look at what the template file has in it, the template file just simply has a curly brace, so a $ curly brace, and then a variable name or value name. And so it basically extracts that out of the map that I sent. So if the map has key values, then I grab that key and put it inside of curly braces, $ curly brace, and the template file function will replace that with the respective value coming out of the map. So that's an invaluable function, and this is a very simplistic use of it. I have more, I guess, tedious examples of that too, but this is an easy one, I think, to grasp. So I use the TF-TPL to then generate a provider.tf file. And in this case, I'm writing the contents of that template file function into a local file. And so the local file provider then will create the provider.tf, and that's basically it. So now Terraform owns the creation and destruction and modification of a file. So as the source contents from a previous run change, they can then modify the target contents of the file in another directory. Super handy. But use cases, I haven't seen a lot of people, as I said, that had a desire to use this. The one I would say the major downside here is that I have a very strong dependency between these two directory locations. They sort of both have to coexist. So they can be separate, and you could have, like, anytime the root module is modified, then it needs to push a modification out to other root modules as well. So there could be a relationship there, but oftentimes the way I use it is both of those directories are sitting side by side within the same project.
Do you ever get into like circular references issues with that? Because
I haven't, because they're separate runs. They're completely separate runs. Yeah, I think that's one of the benefits. Frankly, there's no way that you can modify backend configuration, backend state storage with Terraform code. That has to be done before Terraform even executes, which is why I think a lot of people just use TerraGrunt for that sort of thing, which provides a lot more capability than what this does. But if you don't want to use third-party products, then this gives you a way that you could do that, still being dry. All right, moving into some of the other ones. So I have some code options available to me, and what I mean by the code options is that I'm referring to things that may require you to write code, or may require you to interact with code. So in the case of HTTP provider, this is a provider that just allows you to do an HTTP GET request, and so that jumps out and calls let's just say it's a REST API, and you can pass query parameters to that, and effectively anything's possible at that point within a GET request. And I dare say that authentication is probably not going to happen unless it's just part of your URL string. So it's HTTP or HTTPS, I should also add. But that provider is nice because if you are able to, or if you have a REST API that is already existing within your environment, and it provides some value to you. Maybe it gives access to like a key value store of your own making. Could be console for that matter. Or maybe it gives you some action into a custom job within your company that goes and starts running jobs, right? Tasks. It's sort of open-ended as to how you're going to interact with that and what value you'll get from it. But that gives you a lot of capability to then take out, I mean, the obvious thing, take out values that are being passed via Terraform and put into some other system for them to consume those things. The external provider is another one, and I've actually shown example. I've shown examples on this before. I had to remember if we'd done a video on that. So I didn't do a video specifically on the external provider, but I believe it came up in context to one of the other ones. The idea here, though, being that if I have a piece of code that I've written, then I can interact with that using Terraform. So Terraform can call the external code. That code results in some sort of output, and the output has to be JSON. And Terraform then reads that output directly and natively. So it has to be structured such that Terraform can consume it. And then that can influence, therefore, the conditional logic that Terraform applies to that. So the example that I remember giving was that we wanted to create a resource group if the resource group did not exist. So I call a piece of Terraform, which goes and inspects the provider looking for the existence of the resource group. If it doesn't exist, then Terraform's told to create it by incrementing the count to 1. So it either replies with a 1 or a 0 effectively, and then can create the resource group respectively. Also really handy because it leaves it open for you to write anything that you want, as long as you can take JSON in and output JSON raw through this process, and do everything else that you need to do in between. The downside to this one would be that the external provider tightly links you to a language. It links you to a platform and a language. So when I set up the external provider, I'm also defining that I need you to run, say, PowerShell, and here's the file name. So in that example, if you wanted to run this on Linux, if it doesn't have PowerShell core installed, then it's not going to work. So you would have to be mindful about platform differentiation there and either create something that is platform agnostic. Good luck. There are lots of things that are platform agnostic, but it requires prerequisites being facilitated. Or you just have to ensure that this always runs on the platform that you intend for it to run on. It's now a requirement. If you want to run this code, it has to be run on Linux or run on Mac OS or Windows, whatever. And then the last one in this example is the custom provider. And this one literally sky's the limit, because the custom provider now gives us an opportunity to create our own provider that interacts with our own environment. And so we can build a whole provider. And when I say provider, I'm speaking of things like the AWS provider, the Azure RM provider, the vSphere provider. Any of these are like mega providers, but what they do is facilitate your ability to talk to APIs within your environment. So it's taking HCL language, just basically key value pairs, and turning those into instructions for some API to go and do magic, right? And I was about to say build infrastructure, but technically, if you build a custom provider, it can do anything. It can do config management. It could turn on a light over a door. It doesn't matter. The sky's the limit. So I think that's really a great path to go, but it also is the most complicated, the most difficult. However, and I'll put a link to this in the description, Terraform provides like a tutorial, a getting started for developing your own custom provider. And it's very simplified. So I think a lot of people could probably follow that successfully and get some results. Now, whether or not you can extrapolate that into something that serves value within your enterprise depends greatly on what your use case is and what the systems are that you have to interact with. So those are code options. And then the last one is workload itself, and this is probably a little more common, I think, because most people are thinking in terms of workload. And so if I am deploying Kubernetes clusters and doing deployments, things like that, then I might be using the two that I have listed here. I have config map and secrets. So I might be using one of those to pass values into for my applications to then consume. And if I'm doing, there are several of these cloud providers that allow some sort of app config. I know Azure's is called application config or application configuration. And that provides a native context wherein you effectively pass key value configuration stuff into the app config, and then the apps are associated with that app config, like a profile. And so then all of those config values are made available to the application. So convenient. And then lastly, there's the cloud init provider. Cloud init is a big, complex beast, but cloud init is, it's OS automation largely. So if you can, so it could be a script. I've done examples where I've written scripts. So again, going back to creating files, I've used template file to create scripts with values being passed in from Terraform. And then I use Cloud Init to pass those files into the operating system and execute them. So that's merging the infrastructure as code and config management constructs, which is a no-no, but has been done. Or it could be as simple as just passing in environment variables that you want to exist on that virtual machine. I think it's only virtual machines. You want it to exist on the virtual machine when it comes up finally. And so that's a really useful concept as well. So those are all the ways that I could think of to pass values around, move them around within and without Terraform. If you can think of some others, certainly let us know. If you think I'm mistaken or you want to contest me on any of these, let's have that conversation. Join us on the Discord. And as always, thank you for liking and subscribing. Talk to you next time.